Lesson 4.3, 1 and 2-step equations. Solving 1 and 2-step equations requires doing the opposite operations in a specific order, backwards from the order of operation. We did 1-step equations in the previous module, and that included problems like these, where the first step was to identify the operation, and then the second step was to perform the opposite, but we're actually only performing one step. So here I had 18 times x is equal to 6. So I divide both sides by 18. 6 does not divide by 18, but we can reduce this to a fraction of 1/3. Here I have x minus 3, so the opposite operation is addition. So I add 3 to both sides, and I get x equals 8. Don't forget to always perform the operations on both sides of the equal. Okay, x divided by 8, so the opposite operation is to multiply. These will cancel, and that gives me x is equal to 88. And x plus 14, I'll subtract 14 from both sides to get x is equal to negative 11. To solve 2-step equations, we have an extra step. The variable has had 2 things done to it instead of just 1, and we have to undo both of them. So if I see 3x plus 5, what that tells me is that 3 was multiplied by x, and then we added 5. Here, 2x minus 1 means that x was multiplied by 2, and then subtracted 1. X over 7 plus 9 means that x was divided by 7, and then had 9 added to it. And 2/3 x means one of 2 things. Either x was multiplied by 2/3, or x was multiplied by 2 and divided by 3. And they both mean the same thing, but it depends on how you want to look at it, because you solve them a little differently depending on how you see it. To solve the equations, we do the order of operations backwards. So when I see 3x plus 5 equals 17, the first thing I want to do is add or subtract. Now, order of operations told me to multiply or divide first, but since I'm undoing, I'm moving backwards. So here's a plus 5, so I'm going to subtract 5 from both sides, and that will give me 3x equals 12. Then I need to multiply or divide to undo what's already here. So I'll divide both sides by 3, and that will give me x equals 4. In this example, I add or subtract, so I had a plus 9, so I'm going to subtract 9 from both sides. Oops. Helps if you actually subtract. Then I multiply or divide. Since we had division, multiplication is the opposite operation, so I'm going to multiply. Now, a fraction like this, 2/3 x, can be solved in 2 ways. 1 as a 1-step problem, and 2 as a 2-step problem, which I did do this in the last lesson, but we'll look over it again. As a 1-step problem, I multiply both sides by the reciprocal. So I take 2/3 x is equal to 14, and I multiply both sides by 3/2. Now the reason that I do this is because if I have 2/3 x, this is 2/3 times x, and the opposite operation is to divide. Well, when I divide a fraction, I multiply by the reciprocal. Okay, so once I've done that, these cancel each other out, and I'm left with x is equal to 2 goes into 14 7 times, and 7 times 3 is 21. Now the other way I can do this is as a 2-step problem. I first multiply both sides by the denominator. That cancels the 3's, and I'm left with 2x is equal to 42. Then I divide by the numerator, and I get x is equal to 21. Sometimes the fraction can cause a 2-step problem to act like a 3-step problem if we're doing the 2-step method. So first I'm going to add or subtract, so I subtract 7 from both sides. 13 minus 7 is 6. Then I multiply both sides by the denominator, and I get 4x is equal to 30. Then I divide both sides by the numerator, and I'll get x is equal to 15 over 2. Or I can add or subtract, and I get 4/5 x is equal to 6. And then I can multiply both sides by the reciprocal. These will cancel, and I get x is equal to, well, 4 doesn't go into 6, but they do both divide by 2. And then 3 times 5 is 15 halves. So you see you get the same result no matter which method you use.